Setting up your meeting. Okay.
This content's being sent to a third party.
And
All right.
looks like we are here. We are here. Looks like the chat is up. Too bad I won't be able to, well, I'll see if I can bring it up on the phone and monitor the chit chat if there's any. I mean, we'll see how many people actually hear because of
The
the
Super Bowl.
the foosball game. But
Foosball game.
everybody can come watch later.
I'd be willing to bet most people are not actually watching the Super Bowl if they're planning on watching what we're doing.
We are
Yeah.
competing with two events. We're competing with Super Bowl and we're actually competing with active space weather. So this is
Oh yeah.
really
Oh
we're
yeah, because
we're
people are
we're in a
outside.
bind.
Well, so far Kathy's here, my friend Kathy. That's it. Well, I should have just invited her over because she lives in downtown Chicago. But she's like, I can't believe you aren't watching the Super Bowl.
Like, is it that hard to believe though, really?
Space weather or bust. That's what I'm going to respond back to. Well, anyway, so today we're going to talk about flux ropes for those who are here and want to watch. This is an interesting topic for all of us. Christian's quite well versed in this, so he's going to drive most of this. I'm just, going to learn from this thing, and those of us, I am supporting my Super Bowl thing. I got my Eagle shirt on. I said I was going to, tear up the city Philly style, no matter what happens, but I'm a little tired, so probably not.
Doesn't that mean literally tear the city up?
Yeah,
Like actually physically
you
tear
know,
it up?
like scale up the light poles and things like that.
Okay.
That's fun.
Wasn't sure.
But before we get into flux ropes, we'll talk about some current space weather stuff because we do have active conditions. We are under the influence of a coronal hole, and we can bring up the real-time solar wind data to go over that.
I
And
gotcha.
Right.
yeah,
Let's do that.
let's do it.
Yay. Oh.
Displayed.
So we had some interesting space weather conditions because just before coronal hole and the CIR, because this is a returning coronal hole, arrived, we actually got a hit with the CME.
You did.
And it arrived, if I'm not mistaken, sometime around early February 8th in UTC time, so kind of middle of the night for North America. Yeah, no, evening
Really
for
hard to
North
find a
America.
starting point for that.
It really is because it came unannounced. It didn't knock on the door.
Yeah, there was.
There was no shock with it, and BT just slowly crept up throughout the entire passage of the CME. It started with a nice southern field. So, where's that southern field? Oh, can
I don't.
even earlier because probably there was a little bit of draping of the magnetic field that was ahead of it. And then it transitioned to the SEN flux rope, and we will go over that. But it induced some storming, kind of late for North America, but nice for Alaska and not too bad for um, Southern Hemisphere. And you can almost tell where it ends by looking at BX because it was a glancing blow, so BX was fairly strong. And it ended, oh, let me see. Let me pull up my screen too.
We're about there.
Yeah, just about there.
5
So
UTC.
this was a slow CME. Speed never picked up. If anything, it actually slowed down. And
Mm-hmm.
it's not unusual for some CMEs. So solar wind is interesting because it will accelerate some CMEs if they're way too slow for the flow. And it will drag some CMEs down if they're very fast. Obviously, if you're going fast through tight space traffic, you're gonna slow down. But some of the CMEs kind of get the push from behind, so to speak. This was one of them because what was the slowest speed? It never got to even 400.
350 is the highest we got.
Oh yeah. So this CME got dragged over here, kicking and screaming. It did not want to come. And it transitioned to Northern Field toward the end of it. And what's interesting about this again, BT kept going up. For some CMEs that come before the CIR, before that compressed region, that's apparently not that unusual. there was a study that looked at interaction between CME and co-rotating interacting region, and kind of the back of the CME, the very end of it, can get compressed, and every time you compress a magnetic field, it actually gets stronger. So that increase in BT is not really surprising, and we're likely to see more of that because, again, we're kind of in the coronal hole season, and some of the CMEs may be launched ahead of incoming CIR, and it will be interesting to watch. So we'll get more statistics on that. Some of them get embedded in CIR, some of them come behind. So it's going to be very interesting season of interactions. But we finally got the CIR coming through right now as we speak. And you can tell that by increase in density. So it wasn't that dense during the passage of the CME, but density picked up even further. So density was already above the normal, the ambient conditions. It got compressed even further. Speed was slowly creeping up. So this is a pretty typical picture for very nice looking CIR. And it came with a little bit of the southern field. So BZ definitely, yeah, we can probably just get rid of the BX at least for
Boop.
now. Yay. Yeah, and BY. Well, why not?
Why
I mean, I
not?
guess we're just
So
dealing with
we,
the kernel hole, so
yeah, we got a couple of intervals of very nice southern um wind, and it definitely got
we saw G1
magnetosphere
today, I believe.
busy. We reached G1 for sure, and that was a nice substorming too.
Yeah.
Now I can probably pull up the Aurora Electrojet for today. By the way, Aurora Electrojet is back. It's
Yeah, it was down
exciting.
for a little bit.
It was down. They were doing some work on the page, and testing it involved making it unavailable, and that um, was not removed when work was done. And as a result, page was page was not accessible for a few days, but now it's back. Yay! We
So
love it.
we have AE back, yay.
Yay!
It's important for us
So
Florida Pacers.
as you would expect, there was some southern field that came with the CIR and created some nice substorming. I can probably pull up the Glendale app. It shows pretty much the same thing.
That 1600
Um,
UTC one looks nice.
Yeah,
yeah,
pretty good.
this one's pretty good. And we still got active conditions, and I would say it's about to get pretty busy again because we do have, let me switch to this and actually go to 1 day because it's about to get very interesting. We have a flip coming in. So this is what we have incoming, and it's about to change pretty dramatically. So this is a very sharp transition, and then it pretty much goes into what you would normally see for coronal holes, kind of low and probably fluctuating BZ. But that sharp change is very helpful for making substorms. So expect some busy activity. You don't see it yet, but it's definitely coming, and it might get interesting for at least northern tier of the lower 48. If you
Alaska's gonna have a
have,
good night tonight.
yeah, if you have fairly quiet, well, if you have dark sky and clear sky, that would be helpful. But again, we have moon hanging out with us for pretty much entire night, and unfortunately can bleach aurora quite effectively.
Oh, we are near a full moon. Oof,
Yeah, 92% illumination.
Yeah,
So,
close
we're-
enough.
yeah, that'd be problematic for
so anyway,
photography. Anyway, that's where we at. And then with coronal hole, of course, typically fluctuating BZ and kind of slightly elevated BT. So still substorming is possible, but not as intense. Alaska's going to have a good night, that's for sure. It doesn't take that much for them to get a
no,
substorm going, but we got conditions that are just enough for them, and we just do not have anything left out of this CIR to last for mid latitudes. So if you're
Of
planning
course.
to go, if you were planning to go and chase Aurora after Super Bowl, I have bad news for you. At mid latitudes, it's probably not going to be possible.
Mm,
Some
no.
some flare-ups where you kind of catch a little bit of red or pink above the northern horizon. Still a possibility, but probably nothing major.
Yeah.
So for the
Actually,
diehard people that want to capture every show,
Yep.
do you have that video accessible that Lindsay sent with the pink?
I can get it pretty quickly, actually. Yeah, that's
Because
a good idea.
that
Oh,
video
the
is
nitrogen fringe.
so cool. So basically, we're gonna show you what this translated to in Alaska the other day. It was
Ah, there it is.
quite something to see. So yeah,
All right,
okay.
make
Share
sure
that.
it loads full quality.
I mean,
Okay.
I want to see it again. So yeah, watch this. Look at that.
Just real time and
Real
real
time
vision.
video. Isn't that wild? Isn't that something?
And that's Lindsay. Thanks, Lindsay.
Yeah, thanks, Lindsay. This is amazing. I mean, but this is a good thing to show too, because this is because they, when you have moonlight up there, it actually helps this, like you can see the whole
Brings the
foreground.
color out more.
It brings the color out more. But that's something that's, advantageous about being up at those latitudes and being pretty much at the source. But anyway, that happened the other day when this that was the CME, I think, that hit. Or
Yep.
Yeah, yeah,
yeah,
beforehand.
CME. So you get some pretty cool stuff up there, even with these relatively minor glancing blows and things or enhancements in solar wind. So
That's
that's
Arctic Aurora for you.
Aurora. This is pretty cool. So anyway, enough on that. We'll get to the main event, which is Christian's going to take us through some flux ropes and explain it to us. So hopefully you guys
At
will
least
enjoy
your quick 10-minute quickie, I guess we'll call it,
that.
because there's really this is probably best during an hour and a half session to be a little more in depth on it. So this is going to be a very, very quick run through for most people so that they at least have an introductory idea to what this will be. We're going to look at some of the physical structure of it, or at least what we have theorized and photoed, and then we're look at what it looks like in the real-time solar wind data. There was at the Aurora Summit back in 2023, I want to say. I also did a presentation regarding this during the April. Actually, this would have been 2024 because it was the 2023 storm. Yeah, I'm going to need the slinky at like I think slide 4 or 5. But the point is, magnetic flux ropes. So what are they? Going forward first, just as a brief summary and a reminder to everybody, the sun is a plasma. Plasma is the technically fourth state of matter, even though it's actually the most abundant form of matter in the universe. But it's when a gas has been stripped of all or some of its electrons, either through a current passing through it or some sort of heat. Regardless of how it's done, it means that that material has conductivity and it can be affected by magnetic and electric fields, and it also can have a magnetic and electric field of its own. In this case, the sun is all plasma, the solar wind, therefore, is plasma, and any of the structures that the sun has, such as filaments or prominences, same thing in this case, are all made of plasma. This means they also contain a magnetic field. And we all know that when they're launched, and I have the really cool photo of, I believe, the October one. I don't remember specifically. No, this was May. This was one of the big ones in May. But the idea is once the plasma is launched in a coronal mass ejection, it essentially maintains the same magnetic field that it had when it left the sun. And as that's called a flux rope, or at least one of the structures is called a flux rope that is embedded in the core of that CME. Oh no,
What did you do?
where are my photos?
Oh,
Oh, I
oh,
think it froze actually. So that's fun.
oh, that's fun. Well, we'll give it a second. Oh, wait.
No,
Or was that the
that's like the last slide. Okay, okay.
no,
We're
we're
good.
back. Okay.
Now I'm the one that's gonna have technical difficulties today. Okay, so as everyone knows, the sun has coronal loops too, and everyone loves looking at them. This is the AIA instrument at 171 angstroms. You have the very hot plasma following magnetic field lines from a positive end going up and then a negative end going down. The fun thing that I like to remind people about is when a charged particle, such as electrons or any sort of ions, are in a magnetic field, they don't follow the magnetic field line as it is. So if you have a magnetic field line pointing up, you don't have a particle that gets pushed up with it, it twirls around it. It's called a helix pattern, at least. So they twirl. They do these little spinnies around it, so they'll twirl out of it and then they twirl back into it. And I really like using that word. Sometimes, though, when you have a complex, and I love the diagrams on here, but you have a complex enough region, these are the magnetic field lines that the particles are following through. So these are the actual kernel loops that we would see. Sometimes they can get pinched. I believe it's called an X formation. I'll have to remember the actual terminology for it later on. But these are magnetic reconnection points. You've got a, we'll say, positive line aligning with a negative line. When that happens and they touch, they merge and release a ton of energy. This is enough energy to escalate the CME, or the flux rope in this case, off of that configuration, and that's what launches it into space. So you have, these are the X points here. It reconfigures the sites. So then you just have the post-eruption arcades, the Ps. Love those so much. Really pretty arcs that just start dancing after a big flare. And then you've got the actual flux rope that is thrown out into space. And again, there are particles that are twirling around this little croissant, as we're going to call it, because it looks like a croissant, or a slinky, really, in this case,
Yeah,
which Mary Beth has our slinky example as to how it looks, because that's really what it is. Since these particles are all traveling in a helix, you have curls everywhere. But you still have a magnetic field orientation and direction in this, as far as, well, it depends on how it hits the Earth, though. So the next one, oh yeah, the next one's an actual example of how it forms. So this is a simulation on the bottom of how that would show. It's showing the coronal loops being pushed together and twisted. And then once they are twisted enough, they have an X point here and can recombine from that. And then that can launch off into space. This is an actual photo of not SDO, but I believe this is the SOHO EIT instrument rather. Instead, I think that says 2002, but it's really hard to tell. But the idea is all these kernel loops and the shapes they can take when you have magnetic field lines that reconnect in an anti-parallel direction. So one up, one down, you've got an explosive result and they end up getting shot out into space. This is an actual photo of it in Glasgow as well. The CMEs that are shot off from the side that are very well defined, at least, you can see the actual structure for them. So you have a front, or the shock that's in front of here. That's the material that is escalated or ejected outward during that flare or whatever event is occurring. You've got buildup of material in between, which is usually hollow. It's called a cavity. And then you've got the flux rope, or the core of the CME, which you can even see the slinky pattern. It's curling around this way. So this is probably the best example I have because it's the most photogenic, really. Oh, actually, I have a secondary one that Tanya made for a video. I did slow this down a little bit.
Neat.
Oh, not that slow, geesh. That's
I'm gonna
right.
say I did not make that video. This is from
Oh,
Lascaux
did you find it?
Archives.
Oh, okay.
I thought you actually put the frames together. Okay, we'll let this go 1 frame per second just so we can see that there's gonna be a CME shootout here on the east side. And it is honestly perfect when it comes to structure. You've got
Yep.
the shock here, you've got the cavity, and then you've got the core, the flux rope spinning around it. So anytime you hear us say things like flux rope, we're talking about the magnetic structure at the core of a CME. That's literally just the definition we're using.
Beautiful.
Going back into here, when you hear of classifications, because we do this a lot too, you've got northwest, south, east, or we just talked about the current one, we'll say is a southeast north configuration. Since you have the particles spinning around, you have an axis direction that they're spinning around. So you've got an arrow in any given direction, and then you've got them swirling around. Now, are they swirling around clockwise, or are they swirling around counterclockwise? That's kind of what the differences are here. You've got a left-handed type or a right-handed type. These are the 4 configurations that they can be for each handedness, as it's called. And then you have the actual directions. So if they're low inclination, they're arriving with a very small angle. They're mostly horizontal towards us. Or you've got high inclination when you're nearly vertical, in which case 70, 80, 90 degrees. And this gives you your axes as to, is it going to be mostly a southern field, mostly a northern field, or a mix of both? The bipolar ones, as they're called, are going to be the more horizontal ones, because the first half of that, you've got the magnetic field line pointing all south or all north, and then it will rotate to turn the other direction, either south or north. If it's a high inclination, you have it pretty much aligned, so you're going to have a strong northern field or a strong southern field. We mentioned that it was a southeast north for the one we saw in real-time solar wind data, so bringing that up is what I wanted to do next. as a real example. I do have a more clean example to look at instead. But turning on BY, because we need that in order to know what the directions are, we'll go about to here. Now, I want to stress this because this is it's fair to think, but most people, once they start getting the idea of what it is, see any general rotation of the magnetic field and then assume that that is a flux rope. That's not always the case. It still can occur generally just out of happenstance, or if it's, let's say, some other events. Let's say it's a planar structure that's just stationary that then immediately goes into a different structure. It would look like it rotated too sometimes. You have to check the temperature. Generally, in the core of a CME, the temperature is much lower, almost by a full order of magnitude. So it can go from 1 to the 10 to the 5 to 10 to the 4, as an example. This one was messy. It really was either a side hit. It might have been influenced by the CIR. There's a lot of influences. So this is by nowhere means smooth. But you've got we're going to say it starts here, an all southern field. You've got BY being about 1, which means there's almost no Y field, we'll call it. And then as time goes on, you have BZ slowly increasing outside of these small little bumps here. And you also have BY slowly increasing. BY positive is east as far as direction is concerned, and BY negative is west in the exact same sense that BZ being south is negative and BZ being north is positive. That's kind of the same nomenclature. So then you have BZ crossing 0 and going into the positives. Now, again, this is pretty messy, so it doesn't look as smooth as it could be, but you've got a southern field to begin with. You've got BY increasing to be eastern, which is now most of BT. So here, let's say you've got 10 nanotesla for BT. BY is 7, whereas BZ is -1. This means the field is generally aligned with the Y direction at that time, which in this case is eastern. So you've got a field that's southern and it's moving towards an eastern direction, and then it ends in a northern direction with a high positive BZ. So that's really all that flux ropes are in real-time solar wind data, at least. My favorite example, and the one I will always go back to show people, is the April 23rd show.
Because it's just like a textbook.
It really is. There's a few weird gaps in it, but honestly, it still worked out pretty well. So you had the big impulse that we had just show up. So this is the first phase of a CME. You've got that shock front from ambient solar wind conditions to CME conditions. You've got, after that, it's all called the sheath. And a lot of people start thinking that, okay, we're in this type of a flux rope. I see that a lot as well. The sheath has no meaningful way to predict or recognize what the field direction is going to be. We were lucky in this case that it ended up being as south as it was for the arrival of it. It could have oscillated quite frequently. It could have been north. It could have been a mix. There's no way to tell. So to say anything about what the actual flux rope of this is before it arrives, well, you can't do that, basically. So you've got the sheath as a chaotic, no way to know, just hopefully it's got a negative BZ moving on. Usually that's going to be a potent if it's negative BZ as well, and in this case it was, because that's what you're hitting Earth with. Then you've got the core, which is signified generally by all of the zigzags here in BT, BY, and BZ smoothing out and becoming fairly constant. Again, there's a few weird parts that are bumps here that can be just anomalies, weird structures it picked up on the way. I mean, it could really be anything. But the idea is the magnetic field strength is steady. I mean, if you look from this point on, it's almost a straight line that's just slowly descending, as are the BZ and BY values. The other part to notice is the temperature becomes less erratic. Normally it would drop quite significantly. So I got my screen in the way. There we go. So it drops about here as far as significance goes, and that is where I would say it would really start. Here, just kidding. I don't have alignment there. So you got the temperature that's averaging up here, so about 10 to the 6 Kelvin, and then it drops to about 10 to the 5, which is going to be your sign that, okay, we might be approaching a core now, and then you've got a steady magnetic field as well. So for the case of the April 23rd show, we had all of the field started at south, which was, I think, -32, if I remember right. It was something that we hadn't seen in a very long time. That field slowly gives way. Oh, and then BY is 0, so that's another sign of it. BY then begins to decrease throughout the entirety of the CME traveling through. This means that it's heading in a western direction. So you've got starting south, then you've got a western, and then BZ crosses 0 and goes north. Ultimately, the magnitude of BZ being north will be greater than BY is south. That tells you that you're in the northern part of it. They're called the leading field, the axial field, and the trailing field. So the trailing field in this case was north, the axial field was west, and the leading field was south. This is useful because you can usually use it to tell how long a CME core could last. Can also help in identifying what you're actually seeing or what kind of structure it is as to whether or not you know to go out. So for example, when this showed up, we all knew that we were good because it started out as an all southern field and was slowly increasing. So we at least had 3 or 4 hours minimum before we would start seeing a weakened field. This allowed us to go out early and catch it. So that's why that was such a widely known event, other than it being a big G4 episode, is just because we had the ability to know, okay, we're in all south field, we're in core, what's not going to be changing, so we've got hours to go now. I want to say that was it for at least the slide deck. And I also wanted to make sure there was a little bit of time for any sort of questions.
Yeah, I'm looking at the chat. I brought it
Yeah.
up on my phone.
Okay.
Look,
That's
but
the last one I have on there.
it looks like so far, no big ones that I
I
see.
know that was kind of a quick, rough summary. Given, 20 minutes of time, the idea was to be short-ish, but the idea is, or at least to summarize, flux ropes are magnetic structures in the core of CMEs. They have generally a predetermined direction, though the variables that tell us what the direction it will be when it gets here is a little too much for us to know right now. And we can recognize them in solar wind data by temperature dropping as well as the magnetic field smoothing out so that it's not so jagged, it's not varying. Now that will be heavily dependent on how much of a hit is the CME. Are we just getting a glancing blow from the side? It's going to be messy like the one we saw earlier in current solar wind data. Or is it a direct hit, in which case it's going to look more blunt like this one? So we're just
Yeah,
going to
that's a good point to bring that up because a lot of this stuff will look very messy. And most of the time, actually, they actually look pretty messy and hard to pick out in solar wind data because of just how they arrive or if they're arriving in bad, like in May, we had several that sort of kind of arrived almost on top of each other. And then like if we start get like go back to the example today, like you have a CIR on the tail of it. So it just gets it can be we love to use this April storm because it's like it's such a textbook. Like it was really the only event, and it was like a direct hit. So you could just see the whole structure like just beautifully. But 90 probably 99% of the time they don't arrive like that.
I mean, there's been very few, at least since the max began with this cycle, that I have actually seen and recognized as a smooth flux rope example. This is
Yeah,
definitely one of the smoother ones that from April at least. And then, like for example, the May storm and the October storm, neither of them were very constant. So it was pretty difficult to tell. Given the April one, it was a slew of CMEs, and then October we had that weird planar structure that just didn't have any rotation to it. That was all southern, so I'm not complaining. But the
yeah,
idea is, and I like that you brought this up, Mary Beth, because yes, we have it's a south, east, north. So we had all the southern field here, all the eastern field here, and then it went north right about here. Normally that's when BT starts dropping. In this case, though, it did nothing but increase as it started leading its way up to the CIR, which this was also fun. The coronal hole was a negative polarity, which means phi is in the towards position, and we had purely an away orientation before that, which means you can see exactly when the CIR started hitting when you start seeing the mix in between polarities here. And then you know when the coronal hole starting officially because BT is going to start dropping, which over the last 20 minutes, we have
yeah.
now 8 to 7 nanotesla BT with BZ -3. BZ is now going to start oscillating around 0. So I wouldn't be surprised to see it hit 0 or maybe even 2. In fact, actually, it looks like it's kind of already doing that. Oh yeah, look at that. So it's still technically negative, but now it's going to start averaging up a bit more. BY is almost 0 too as far as hovering. That's where it's at. If we enable BX, which is the radial component, which is mostly what the kernel holes are, it's going to be pretty much maxed out as a positive value. Because for some reason, positive BX is defined as a negative polarity hole. Sorry, I know it's been a while since I've ranted about that point, but bring it up there.
I don't. It's
It's all good.
yeah. I mean, I still can't keep the direct uh I can't even talk to the BY component like oh yeah west is east or no west is like negative or positive. You know what I mean? I
Yep.
can't.
Yep.
I'm just gonna shut up. I'm just shut up.
But you're right.
Yeah.
West is negative, east is
Yeah.
positive. And again, it's just an arbitrarily defined orientation. I mean, it helps or doesn't help rather that we have east set to the left
Yeah.
instead of to the right as we would on the globe because we wanted to keep it consistent within our frame of Earth. When have we ever done that in science for consistent reference frames? Like that made no sense to me. This isn't a ranting point about coordinate systems though, so I'll drop it.
But
Yeah.
the reason we like the slinky too is like because it's a helical field, so this is like your, south of like well this would be um the low inclination one.
Yep.
So south and north. But then if you put your finger through it, then that's your axial field through the
Yep.
middle. So it's like a really good of course I can't stretch it out and stick my finger through it, but so it's kind of a good little visual. Like
We need a mini slinky.
you have the one running through and then the
And then
helical.
whatever direction that it's twisting around gives you what the first two
Yeah.
components of that were. So let's say you're holding your finger that way and it's twirling that way. You've either got a southeast north or you've got a northeast south if it's going the other way. Yeah,
Now,
slinkies are perfect for that.
let's go through this. The most geo-effective ones
So
out
of
of them.
course we do want southern fields pretty
Mhm.
much. There's a kind of well double-edged sword, we'll say, with the ones that have an axial direction all in the
Yeah.
south. So the east southwest, west southeast orientations we have an all southern field, which means BZ is going to be negative all night. So likely, if it's a big one, sawtooth events would happen, which
Yeah.
means we have what 3 hours to wait between each substorm. Real annoying. Then again, the other one being the bipolar ones, southeast north, northeast south, da da da. On a general average time period, your BT value is going to be stronger at the beginning, which means you'd rather have the southern field at the beginning rather than the end of it
You'd want
as
that
the
strong.
trailing field's weaker.
With one exception, if it's being chased by CIR,
Yes.
then
Yeah.
And
you're gonna
it's
end up
fun because they
with
all have exceptions.
increase in BT toward the end. So the north starting, north leading, south trailing will give you more storming toward the end of the CME pass. It's
That's the
kind
only
of
time you'll want it.
strange, but that's pretty much the only time you want it to end up with south because usually the BT will drop over the passage of the CME. So over time, BT will start to decrease, and even if it's southern field, well, it's going to go away. It gets more interesting from the historical perspective. The flux rope had a different name. It used to be called magnetic cloud. So you'll see those terms interchangeably in literature, and when you see magnetic cloud, that's basically a flux rope in the CME core. That's the CME core. Flux ropes, another thing, if you're seeing something that looks like a flux rope in solar wind data and there's no CME inside, chances are you're seeing a flux rope. They're ubiquitous. It's one of those big structures that you're going to see in solar wind, even if there is no CME, because that's what sun is doing. Sun is kind of shedding unnecessary twist, and it will do it in small chunks that are basically blobs. We talked about
Blobs.
yeah, we talked about blobs a little bit. We also talked about kernel streamers, so streamer blowouts. They are also flux ropes, and they can show up as either big CMEs or smaller ones. So flux ropes exist on all different scales, and you can definitely pick them up in solar wind. You will not see the typical features of the CME, so that would be a change in density. Usually the sheath is fairly dense and then density drops, and same goes for temperature. So normally for the semi core temperature drops. Other exceptions? Yes, of course.
As always.
Everything, yeah. Every time you start to see several structures interact between each other, all those rules, how we call CME core and sheath, that just goes away. It's going to end up messy, it's going to end up twisted, and it's going to be kind of all at once.
Which again, our
Um,
October and May, both of those events magnetically were very, I mean, we
They're
still have a few
pretty,
very
more.
odd.
So
yeah,
let's do
odd.
this.
So,
But if
yeah.
Christian, if you can pull the picture of this CME in the coronagraph, there's some other interesting thing
Oh, which one?
to point out. The coronagraph for the CME.
Oh, the one you up for this one?
Even the previous one, you had one that was
Oh,
in
on my slide. Okay,
the
gotcha.
normal. Yeah. So if you look at that flux rope, normally when they're depicted, when people are trying to show, yeah, CME flux rope is flying away, it's going to show it's sort of like croissant-like structure. Nothing could be further from the truth because they often end up twisted and broken down
Bumpy.
so they can arrive in all sorts of different shapes and forms. But that twist and that deflection when they're not flying in the direction you expect them to fly, and that rotation when they're flying away and twisting at the same time, that's why it's difficult to predict, even if we know how that structure started on the sun.
Yep.
How it's going to arrive to us is anybody's guess. We can't really track them through space. So if they rotated or deflected,
Will not know
we're
that.
going to see something, but it's going to be nothing like predicted based on the structure on the sun. So all the prediction models that show, yep, this is how it's going to look like, and this is going to be the type of storming. And there are some models that will do that. They're still experimental, so they're in research stages. They do have a huge margin of error. And that's why we can't really predict geomagnetic storming and aurora based on just looking at the CME as it erupts and leaves the sun.
Yes, good point. Because that's, I know, well, obviously all we want to be able to do that, but we just don't have,
So desperately want that.
we don't have anything to really watch it, in between when we see it in the image, like out in the sun and when it gets here. And there's just so many things that can change these structures. And that's why people are very careful about trying to predict it, at least more reputable people, I should say, like Tamitha, because there are ways you could figure it out by looking at these pictures, but is it going to arrive here that way? Maybe, maybe not. So it's,
Out of all
it,
the ones I've looked at, I'm about 50% of them. I'm now, to be fair, that's only a sample of about 8 that I've done as far
yeah,
as trying to figure out what they looked like and what they were. But 4 of them arrived as they were predicted, and 4 did not.
yeah. So it's one of, work in progress. So yeah, the fun part I love about this stuff is, the more you learn about it, you're like, oh, we're going to clear up some things. And then I'm like, well, now I have more questions.
Nope. The more you learn, the more you are aware of what less that you know.
It's like,
Which, to
wow.
be fair, that's a superpower. You want to know what you don't know.
Yeah.
That's probably the most important part of learning.
So now you guys can have fun picking out flux ropes and solar wind data. So fun times ahead for everybody watching.
And we will definitely put the link to Tamitha's original paper with flux
Yes,
ropes.
it's a good
Yeah.
So
reference.
that's a fun read. And there's also a good resource on Austrian Space Weather Office website with all the different flux ropes. And yeah, because CMEs rotate in transit, those nice, smoothly progressing curves that you're supposed to see in the solar wind data, most of the time they probably not don't exist. So as Mary Beth already pointed out, they
Yeah.
just they just don't survive sometimes.
So here we are. But so that's all we got on flux ropes today. Hopefully you guys got something out of this. If not, we're all available for questions,
Oh
comments.
yeah, God, pound us with questions. I couldn't want
Um,
more of them.
because yeah, it's a complicated, like I mean, I'm not going to sit here and pretend that like I understand this the first time around. I don't. And like most people that are, that come from like the Aurora world maybe, or like photography, things like that, and trying, this stuff isn't easy to grasp. Like you can't see electromagnetism. You really can't. So you're talking about things that are, and for us being more visual people, if you can't really see it, it's hard to grasp that concept. So these aren't easy topics by any means. So don't get frustrated or yeah, frustrated, I guess is the word, or dissuaded. It's the nature of the beast. And we're at the beginnings of this, like trying to find ways to communicate these ideas in a better way. So we'll get there. Someday we'll be at the level of the terrestrial weather because they've got it down pretty good now. But it took decades.
Another 30 years, maybe.
It took decades to get that where it's ubiquitous and people are like, yeah, where you don't have to understand the physics and whatever behind it to, be able to even grasp like weather systems that are incoming or whatever. So I like to use that analogy because really space weather is just another layer on weather in general, really, if you think
Yep.
about it. So there we go. No, that's my closing rant.
Well said. Fully agreed.
So I will look one more time to see if we have any questions, but it doesn't look like it. Uh,
Next plan is to blow up the moon on that note.
yeah, you do blow up the moon.
So Justin, there's
No,
your answer.
let's keep it for the time
Yeah,
being because we don't know what that's gonna do
yeah, that
to
might
the
have some.
weather.
I guarantee
So
I know what it's gonna do to light pollution at night.
Well, yeah, but it might
you're
have
not
some.
gonna like it.
It'll have some far-reaching effects that probably aren't favorable.
So you're saying I shouldn't blow up the moon, even though
I'm
I
saying
can't.
you should accept if it is for what it is and enjoy it. I mean, you used to take pictures of it all the time.
I know I need to do that more often. I need to
I mean, you
appreciate
were
it
like
more.
the moon boy
Sorry,
at
Justin. Yeah,
so
the moon was my first. I mean, of course, I think it's everyone's first topic, but first
yeah.
thing through a telescope I looked at and took photos of.
So learn to love it again. It's fine. It is
And
cool.
remember, yeah, and
Maya,
remember,
that sucker.
we are in the coronal hole season,
Yeah.
so they're gonna be coming pretty much every 2 weeks. We just had waved goodbye to the previous coronal hole, and now we have this one.
Yeah,
The
real
other one
quick,
is coming back, and
let's
then
look
the
at that.
moon's not gonna be an issue.
Yeah, so it's all good. But anyway, we'll leave you guys with that unless Christian wants to share anything else. But I think
Oh, I was just gonna pop up the corona hole we got now
yeah.
because
Oh
it's
yeah, because this is
Oh
pretty
yeah,
pretty giant.
very
So this is
cool
what we're
looking.
seeing now, and then we've got it kind of connecting with the other side here, all through here. So we're gonna have now it's still a negative polarity hole. So we're
Yeah,
gonna be under the influence of this sucker for a while. We'll go less influenced for several days as we don't have much of it going, at least
yeah.
longitudinally. But once we get to over here, we'll start seeing it again.
So we got something to look forward to. So yay. And on that note, we'll think of some sort of topic for next week. We'll figure it out and we'll post about it. But in the meantime, let's just do one more thing here. Oh, look at that. Thanks everybody. I'm glad you guys are getting something out of this. So yay.
yeah. And in the meantime, if
Yeah,
you're out to chase, it looks like we do have conditions that are fluctuating, so we may have some fun ahead. Do you want to
give it a whirl. Give it a whirl.
yeah, so Christian, if you want to pull the real-time solar wind data, sort of take a last look and see
One
what's
last
ahead for
one.
the night,
I
for the next
believe
couple
we
of
have,
hours.
so BT is definitely dropping. Expect BZ to oscillate. Like we're basically going to start going down to high latitude substorming.
Yeah,
Oh, that
with
was April.
occasional,
Way back.
maybe occasional flare-ups here and there.
Yeah. But yeah, we're down to 8 BT, nanotesla,
Oof,
and then yeah,
not
BZ and
looking good.
BX and BY are all oscillating around zero now. We are pretty much fully fledged in the coronal hole, but we are above 600 kilometers a second now. So we got some action going.
And oscillating BC. So substorming is possible. Alaska, it's your turn.
Yep, sure is.
We might be done with this. All right.
All right. So I'm just answering a question about because yeah, is it normal for corona holes to be on the opposite sides of the sun? And then I was just saying, yeah, especially in the declining phase because they just
Start growing.
moving down. Yeah, they start growing and moving down. There was a theory, I think Tamitha mentioned it, that these are the old
Oh,
polar coronal hole, like these are old holes, and they're making their way down to basically the equator word, and that's what we're seeing as the new ones pop in.
Yep.
And I think
sorry,
We
Jesse. So yes is the
yeah,
answer.
yeah. So we have new ones now, because the sun did do its flip-floppy, with its polarity. So the theory is that these are the old ones
yep.
being being shed, I guess you could say. So yeah,
And we do have polar coronal holes that are forming. So even the most recent SDO shows that there is one hanging out in the at the North Pole that is freshly formed. I think we saw one in the South Pole earlier. So those do get bigger, and then we're gonna be done once that all of that moves out. But we still have a year, probably more, ahead of us
yeah.
for
Well,
decent active conditions. And again, this is an odd cycle, so geomagnetic storming, at least statistically, has been stronger during declining phase for the odd numbered cycles. So we're not quite done with geomagnetic storms.
Nope.
yeah. If you're
The
not.
risk is there.
All right, cool. Sweet. I think we're
All
good.
right.
So we can call night, so we can let everybody go back to watching American football. If
Or
you,
rather,
yeah.
go do something better like anything.
So please. But thanks for coming. Thanks for joining us on, such a day like this. We enjoy it. I'm glad you guys get something out of it. And then we'll post about what we'll talk about next week. So, yay. So in the meantime, have a lovely
Hey,
evening.
everybody.
Bye.
All right.